Now we're getting to some of our more complicated rules that are a little bit more challenging to remember and to work with. When we had a constant multiple, we could just hold on to the constant times the derivative of what we were multiplying by. When we were adding or subtracting the different pieces, we could just do the derivative of each piece and add and subtract those individual derivatives. But now, with multiplying and dividing, that's not going to work, just because of the nature of how slopes interact when we multiply and divide. So the first of these is our product rule, and there's a different video for the quotients when we do division. But if I have two functions u and v that I'm multiplying, such that f is going to be a function u times a different function v, then the derivative would be u times v prime plus u prime times v. A couple different ways of remembering this. If I think of u as the first and v as the second, then I would have first times the derivative of the second plus second times the derivative of the first. And this will be how you tend to hear Mr. Carrillo remember this, is by saying first times derivative second plus second times derivative first. Other people like to remember it in terms of these u's and v's. So in our example here, the x squared plus 1 would be the u, which is the first function, and the x cubed plus 3 would be the v, the second function, and those are the two things we're multiplying. Now, could I multiply that all out and get rid of my parentheses? Yes, but that's not always going to be possible for us. So this is not a rule that we're able to really work around and avoid. So if I wanted to find the derivative of f here, because I'm multiplying two different functions, I have to use product rule. So I would need first times the derivative of the second, which would be power rule on the x cubed, and derivative of 3 is 0, plus second times the derivative of the first, and this would be my derivative.